Hello everyone. First of all, I hope everyone is fine and healthy. Let me introduce myself. My name is Gökçen Arslan. I work as a research assistant at Construction Management Department of Civil Engineering Department in Akdeniz University in Antalya, Turkey. Today I'm going to present our study which titled with investigation of the effect of risk management on cost performance in construction projects. In the first part of my presentation, I briefly talk about risk management in construction projects. Then I give information about our study's purpose and methodology. Then I'll end with the results and findings we obtained from our study. Now, I'll start my presentation with a brief summary of risk management in construction projects. The success of the construction projects highly depends on the completion of the project in specified time and cost at the desired quality. Any deviations from these targets could pose a great risk in the project. So, successful achievement of the determined targets depends on the systematic identification of the risks, detailed analysis of them, identification of risk plans, and implementation of them in the plan. And this can only be with effective risk management. We know that construction projects could highly affect a lot of risks. But what is the characteristics that make the construction projects or sector a risk-prone sector? These characteristics could be listed as below. Approaching every project has started as a new project. The construction phase takes place in contact with the external environment. The place where it's designed and the place where it's executed different. So this makes uncertainties that can determine the final quality of the project. Generally, exposure to situations that can cause harm to people, to machines, to equipments, even to work itself. A lot of research has conducted in previous studies by different researchers about risk management and risk classification. Some of the classifications made by research is given in the table. In 1985, Perry and Weiss stated that the risks are classified as physically based risks, environmental factor-based risks, design risks, logistic risks, financial risks, and construction risks. In 1996, Birgenen and Bickman stated that financial risks, construction-based risks, design-based risks, political risks, and natural disasters are classified as risks. In 2015, Eker classified risks as internal and external risks, and internal risks were owner's risk, designer risks, contract risks, subcontractor risks. External risks were financial, regulation, policy, and environmental risks. But what is the risk? The advantages of the risk management in construction projects? Kazaz stated in 2010. The advantages of risk management could be listed as follows. It provides a systematic and logical approach to decision making, and gives a detailed analysis of options in complex decision problems, enables the decision makers to face the risks and uncertainties realistically, and it contributed to the communication in the organization and allow decision makers to determine how much information is collected for a decision problem and highlight judgment and intuition in decision making. The purpose of the study is to investigate the effect of risk management on the cost performance in construction projects. For this purpose, a superstructure project was modeled and analyzed for 3 different situations, where the first situation is risks are not taken into consideration. The second, where risks are taken into action, but risks are not responded. And the final one, where risks are included into plan and mitigated. Within the scope of the study, first, we planned the project through Primavera P6 software. Then, basic processes were determined through the project plan and risk analysis, and Monte Carlo simulation was applied on the determined processes. Finally, by comparing the data for the 3 different situations as a result of the analysis, the effect of risk management practices on cost performance in construction projects was examined. For the study, a housing project with a reinforced concrete structural system consisting of 4 basements, 1 ground floor, 11 normal floors, and 1 roof with a total area of 19,200 square meters is taken as an example. You can see the normal floor plan of the project in the figure. The basic process of project, planned start dates, planned finish dates, durations, and cost are given in the table. We defined basic processes as design process, contract process, site preparation phase, rough construction phase, fine construction phase, mechanical work phase, electrical work phase, and the final phase was project control and delivery. Possible project risks for the project were determined within the previous study and the review of the opinions of the planning team. The risk score for each risk was determined by evaluating the risk possibilities and the effects of the risk on schedule and cost. In evaluating the risk probability and the risk impact on the schedule and cost, very low, low, medium, high, and very high levels were used as ratings. The probability and the impact of schedule and cost could be seen in the table. We define 31 risks for this project. These risks are incompatibility between design projects, change of codes during the design process, design flows, change requested by the employer, inadequate and incomplete contract documentation, not suitable contract type for the project, uncertainties in contract clauses, contractual provisions that regulate risk distribution heavily, one or more of the parties, inadequate contractor subcontractor selection, delay of site delivery, limited knowledge about the site, failure to prepare the site plan, occupational accident resulting in fatal or serious injury, delay in material supply, sudden increase in material prices, earthquake, fire, floods, etc., faulty or low quality construction execution, equipment malfunction, decrease in labor productivity, financial difficulties, political problems such as war, coup, etc., difficult weather conditions, management and organizational issues, nationwide strike, failure to achieve the expected quality in the project, disagreement between parties regarding the extension of time, disagreement about the increasing costs between the parties, delay of final checks, prolongation of bureaucratic procedures. In case the risks are not considered, we found the project's duration as 611 days with a probability of 80%, and the completion cost of the project has been calculated as approximately 27 million Turkish liras. In case the risks are taken into consideration but no measures are taken against the risk, we predicted that the project will be completed in 791 days, and the cost of completion will be approximately 21 million Turkish liras. Among the risks identified within the scope of the study, the three risks with the highest time sensitivity were contractual provisions that regulate the risk distribution heavily to one or more of the parties, change of codes during the design process, and inadequate and incomplete contract documentation. Among the risks that affect the cost the most, the first three risks were the financial difficulties experienced by the employer, occupational accident resulting in fatal or serious injury, sudden increase in material prices, and it followed by earthquake, fire, flood, and etc. Disagreement about the increasing costs between the parties, not suitable contract type for the project, contractual provisions that regulate the risk distribution heavily to one or more of the parties, change requested by the employer, inadequate contractor-subcontractor selection, inadequate and incomplete contract documentation. When measures are taken against the risk, it is estimated that the project duration will decrease to 726 days, with a probability of 80%, and the completion cost will be approximately 29 million Turkish liras. As we can see in the figure, duration comparison for three determined situations are like this. The black curve shows that the first situation, which is the where risks are not considered in the plan. The blue one shows us risks are included in the plan, but no measures were taken. And the orange one shows us that the risk responses are planned and risks were mitigated. And in this figure, we can see cost comparison for three different situations. The green one shows the first situation, which is the risks are not included. Red one shows that risks are included, but no measures are taken against the risk. And the purple one shows that the risk responses are planned and mitigated. When the data obtained are analyzed, in case risks are included in the plan, according to the situation where the risks are not taken into account, it is seen that the project duration has increased by 30% and cost by 15%. Besides, the results obtained shows that the effect of the risks on schedule can be reduced by 8% and the effect of cost by 7% with the measures taken against the risks. However, the measures to be taken largely depend on the risk perception and experience of the project manager and planning team. It is also seen that the risk attitudes and management maturity of project owners have a critical role in the risk management in construction projects. We hope that the numerical data obtained from this study will shed light on risk management for project owners and managers, especially in small-scale construction projects. It is also thought that the studies then can be carried out with different types and sizes of construction projects in the future, may reveal the relationship between the main factors affecting the risk management in construction projects and contribute to improving risk management practices in construction projects. My presentation ends here now. Thank you for listening me. Thank you for your time. I hope everyone have a great day, have a healthy day. Thank you.